Welcome back to my channel, Cat by Nagendra. Now let's continue with these remaining options. So next we are going to see here geometric tolerance. So this entire thing, whatever we are discussing here, everything already we have discussed theoretically in basic engineering class. Please watch that video, then only you will understand everything here. So this is my suggestion, then choice is yours. Now geometric tolerance means, so in simple words, we can say GD&T. So by giving dimensions, we are able to specify what is the size we want. But if we want to specify what is the shape we want, there we can use this geometrical tolerance, nothing but GD&T. So just I'll click on this geometric tolerance. So theory I am not going to cover here. Why? Because before only we have covered theoretically. So just I am going to show you how to use these options. Now different type of leaders we are having, whichever we want we can use here, like this with the zigzag. So just I'll go with the normal one. Then either we want this geometrical tolerance table and all, we need horizontal or vertical. So maximum cases we'll use horizontal only. I'll keep it horizontal. Then document font only. For example, I want GD&T here for this line, somewhere here. Just I will click. Then here you will get GD&T symbols. So for example, I want here parallelism. Then what is the tolerance value you want? Let's say for example, I'll take 0.2 like this. Then here datums will be there. So just I'll click on add datum with reference to A. I'll keep it. Let's say done. Now this line we are having parallelism with a tolerance value of 0.2 with a reference to A. So here this is datum. So the datum option we can use by using this datum feature. For example, for this line, I'll create as datum A. So we can change this letter also. We need only A now. It means we are able to give relation between this line to this line. Relation between these two lines we are having here parallelism with tolerance value of 0.2 with reference to A. So this line we are having parallelism relation with reference to A. So like that we need to read this GD&T. So just we can go for geometrical tolerance for whichever we want. Just click there, a single click. Then we are able to select which GD&T symbol you want to insert. For example, I want here flatness. So usually flatness will be used on the top faces. So just for showing you, I am taking this. So again, datum if you want, we can add this directly, can mention like this. That is about geometric tolerance and datum feature. Then datum target will be there. You can see preview here also. So datum target is similar to datum feature. So here 3 by A, 5 by A like that we will get. For example, here. Okay. So this one, whichever the value you want, you can mention like this. So usually we won't use this datum target. Mainly we will focus on datum feature and geometric tolerance. This is very important. Then next we are having here blocks. So here two options we are having. Make block is there, insert block is there. So what is mean by this blocks means, now let me explain you in a simple way. For example, we are having one nut. Just I'll go for sketch. Not only that, any shape, one shape we are having here like this. Now, for example, for this circle I given dimension with a diameter of 3. Then same shape I want and I need to insert that same shape multiple times again and again. So here you can tell that just we can copy and we can paste. But what I wanted is, I want same shape but not same size. You got it? So same shape we want, but we want different size. So in such condition, we can't use copy and paste option. Why? Because we will get same dimension. So in such condition, this entire one we will convert here into block. Make block. Block entitles are this entire thing. Then insertion point. For example, I'll select this point. Okay. So just I will save. Now one block is created. Again, if I want to use the same shape with a different size, just I can go for insert block. Why? Because already we have drawn this shape. No need to draw once again. So directly we can go for insert block. You will get the same shape. If you want to increase or decrease the size by using here scale ratio, you are able to increase or decrease. If you want to rotate also, we are able to rotate and we can keep it like this. So again and again multiple times we can insert by using these blocks. So that is the importance of blocks. Make block and insert block. I hope you have understood about that. Then next we are having center mark. So center mark is maximum like mainly we will be using for circles. For example, the circle is there. The center point we don't have any reference. So center mark for this that line will be created. So for giving dimensions and all it will be useful. And for representation also it is useful. This is about center mark. Then next we are having center line. Let's say for example I want one line between this line to this line. Exactly I need to take dimension half dimension. In such condition we don't have any reference here. So there we can insert the center line between this line to this. Exactly at center one line will be created. You can take dimension from this line to this line like this. That is about center line. Then next we are having here area hatch or fill. So usually if we go for section view under drawing section view, for example with reference to this horizontal direction, okay, if we go for section view, here we are able to get this hatching. So this is automatic hatching when you are going with section views. But in some condition, we need to give hatching manually. In such condition, we can use here area hatch or fill. Either you want to make with hatching or any solid color or nothing. So hatch, depend upon material what we are going to apply also, it will change this pattern. Then for example, I want here for this circle. So I think this is a block, so it's not coming. Let me show you here. So area hatch, for example, this area like this. If you want color, solid color we can mention, or hatching we can mention. So if you want, we can give this offset also, scaling like this. And if you want inclination also, we can change angles. Like this, we are able to make hatch manually by using this area hatch or fill. Then next we are having here revision cloud. So usually this revision cloud option will be used to highlight the parts or to highlight the area. So just if I go for revision cloud, we will get here different types like rectangular type or circular type or free form or again different option. Now rectangular type, just if I draw here, you can see it will highlight there like this. So you can turn off this document display and you can change different type of this line structures. Then thickness according to our requirement we can change. So this is mainly to highlight that exact area like this. That is revision cloud. So then last we'll go here with these tables. Under tables, we are having different type of options. First, we will see general table. So general table means in our own standard, we can create like how many columns we want, how many rows we want. Then let's say, okay, I'll keep it one table here. Now, if we want to fill this, for example, first one, double click there. So first I want here serial number. Next I want name. Next I want like that according to our requirement, whatever the text we want, we can create one general table. Then next we are having whole table. So what is meant by this whole table means this also I have covered in basic class, but now in SolidWorks I am showing. What is meant by this whole table means, for example, if we are having multiple holes and for each and every hole, if I want to specify this position dimension like horizontal dimension, vertical dimension, what is the diameter, what is the depth, entire holes if I give here itself, all it will get clumsy. and it will be not able to read the drawing properly. Why? Because if more holes are there, more information should be there. So one information it will get clumsy. So in such condition, we'll use this hole table. Mainly it is used for multiple holes. Now, how to use that means just I'll go for hole table. We need to select holes. So first this hole, again this hole. So let me select these holes. 1, 2, 3, 4. Then this one also I'll select. 5 holes. I need to create hole table. Then origin point it is asking. So from which point we need to consider origin point, either here or here, whichever. So here origin point where it should be selected. Origin, for example, I'll take reference to this point. Then either we want to represent these multiple holes with letters like alphabets or numbers. So usually we will go with this alphabets or numbers. Anyone we can use. Let me keep it here alphabets only. Then just if I say OK, you will get one tabular column like this. Now you can see already annotation created. First one A1. So this is the A1 hole. For A1 hole with reference to x direction from here, horizontally we are having distance of 30. Vertically we are having distance of 30. Diameter is 25. Depth of 30. Again for A2. So this is A2. What is the dimension? Like that for each and every hole, detailed information will be specified in a tabular column. So this tabular column for holes we call it as hole table like this. So I hope you have understood about this hole table. Then next we are having here bill of material. So this is very important one. Bill of material. I'll explain this. Then revision table will be there. Weld table used for welding. So I'll explain this in weldments. Bend table and punch table. These two will be used for sheet metal design. So after completion of sheet metal, I'll explain these two. Now let's go here with this last option, bill of material. So bill of material is nothing but it is a tabular column in which we are able to get detailed information about an assembly design. It includes part name, part number, quantity, description, entire in detail information about an assembly. If it is represented in a tabular column, the tabular column we call it as bill of material. So this is purely used for assembly designs. Now let me delete everything here and let me insert one assembly. So just I'll delete all these things. Let's insert assembly. Now let me rebuild. Here view palette. Already assembly is there. Refresh. I'll insert this isometric view into drawing sheet. Okay. Now just let me open this assembly. Here different type of parts are there, and let me apply some material for each and every part. So here I'll open this particular part. Material not specified. So mouse right click. For example, I'll apply some brass here. Okay. We need to save. Why? Because these parts I have created in earlier version file. So let it be like this. We'll check. Yes, we need to save it again. Okay. Then for example, for this top plate also I'll change material. Okay. I'll apply some rubber. Save changes. Yes. Save. Okay. So now we have applied two types of materials here. So I applied material for only these two parts. Now just we'll go here with this drawing sheet. Then we can go for tables. We can select here bill of material. Now bill of material for which one we need to generate for this assembly design, right? So just we need to click on assembly. Then here you can see table template will be there. So usually if you are working under a company or something, an organization, some companies they'll be having their own standard bill of material tables, like whichever the properties they want, that will be created separately. So that also I can show you how to create that bill of material standard table. Now, if you want to change this, just we can click on this. Okay. Then you are able to see different type of bill of materials here. So bill of material, all properties are only with circuit summary, are only with costing, are only with material, are only with standard, are stock size, vendor, weight. According to our requirement, we need to select. So if we are having a separate bill of material format, we can select. Now let me show you here with this all. I'll select the bill of material, all I need to show, open. Then just we can say okay. Just we need to select template here. No need to touch anything here. These are all default settings. Just say okay. You will get one tabular column like this. So here item number 1, what is the part number? Item number 2, what is the part number? Again description, if we have given separately, the description also will be shown here. Or else just by double clicking on that you can enter. So either you want to add text with keeping link with reference to this table, or by breaking the link it will ask. If you want, we can keep it link, or if you will break the link, I'll keep it link, enter the text, whatever you want, like this. So if I move, that also will move. There will be link between this text table like this. Now, one thing you can observe, before in this assembly design, we have applied material for this top plate and bottom plate. But if you are able to see in this drawing sheet, we can see material is not showing properly. We have, even though if you have applied material, here it won't show. So in such condition, just we need to go for assembly. Now, for which material we need to show, for example, for this top plate, already material applied rubber, but it is not reflecting in bob. In such condition, open the part for which you need to show that material. Then go for file here. File. We need to go for properties. Then go here with this custom. Under custom, we need to go with property name. Here just you can click on arrow mark. Which property we want? We need here material. Then leave this type. Go for next one. Here again arrow mark. Just click here. Here also you want to show material. Just I'll click on material. Just we can get this. You can see you got rubber. For example, I want to show weight also. Click on weight. Okay, I think material is not better here. Let me change some nickel like this. File, properties, custom. Custom property, we want material. Then value text expression. Here we need SolidWorks material. Just click here. Then it is showing material here. For example, we want here weight also. Then weight will be calculated in here mass. And let's say okay. Now directly we can close this. I need to save changes. If I go for a drawing sheet, automatically it will get updated here. See, for this top plate, material is nickel, weight is this much. Same like that. For example, we want for bottom plate, we'll open this part, file, properties. So this is not for every part. Why? Because in some cases directly we will get this material weight and all with bill of material with if we create that bill of material block in our standards. So this is all I have taken. So manually we need to make it here. Again material, properties, SolidWorks material. Only I am going to show material here. So drawing sheet, automatically it will get updated. See here, material updated. So like that, we are able to customize this bill of material table. So this is about drawing in SolidWorks. So I hope I have explained you in a better way of this entire drawing in SolidWorks. So if you feel these videos are informative, please share to your friends to whom it will be useful. And if you really feel this video is informative, please like the video. I want support from you. So if you are giving support to me, then I'll get interest to do more videos. So if you feel this is informative, please like it. Thank you so much.